limiting factor. These two particular parameters we usually choose. You know that accuracy limiting factor, or ALF, which is the defined of the ratio of limiting primary current over which the accuracy of the CT is maintained to the rated primary current. More or less, you see the previously we used 5P10 class of PT. That means represented as the protection class CT is 5%, and accuracy over the 5% over a current range of 10 times of the normal primary current rating. Even the normal primary current rating given for the CT itself, if the 10 times of the normal primary current rating the current flows, then also its accuracy only affected within 5% limit. That is the accuracy limiting factor, because it is very important for our protection class, because if something we cannot compromise in it, if something happens to it, the entire life may be fatal for it because of the electrical accident or not, and we have experienced all this. So these two factors, while choosing CT, we usually very much careful about these two factors. For power transformer, in case of power transformer, we usually choose oil natural, air natural type of cooling. Temperature winding, core and oil designed for the operation, and altitude not exceeding 1000 meters above the mean sea level. That is usually standard design procedure of transformer. That's why we procure or we purchase a transformer in that, keeping all these views in our parameter. And on and cooling is 55 degrees Celsius for winding. Then we will talk about the insulating oil. Insulating oil, we will talk about. That is very important. And while we procuring the insulating oil, or we choose the insulating oil for the transformers, we usually go for the three properties of the insulating oil. One is physical properties, and second is electrical properties, and third is the chemical properties. Well, in case of physical properties, the density, interfacial tension, flash point, viscosity, pore point, water content is all are considered. For the chemical properties, neutralization value, oxidation stability, corrosive sulfur sediment, or residual sludge usually happens during the operation of the transformer for the long period. We usually consider all these things, but basic three electrical properties we usually look into for the maintenance as well as the design purpose. That is the breakdown voltage, resistivity, and dielectric dissipation factor. Breakdown voltage, rather later on we will discuss about it. That breakdown voltage, we usually put certain amount of 500 ml of insulating oil, and there are two electrodes apart from 2.5 millimeter, and then we put the high voltage over there, and we see the breakdown. If it is below the 45 kV, then we consider the oil is impure or not usable. In case of resistivity, it is expressed in the ohm centimeter. Low resistivity indicates the sign of the presence of the moisture in the oil. In that case, we have to refilter or reclaim the oil, and then comes the dielectric dissipation factor. It is basically the loss angle measurement. The tan delta measurement we usually do for it, or sine angle measurement of the loss angle. This means that if DDF, dielectric dissipation factor, is high, that means the oil is contaminated and it cannot be used anymore. We have to either change it, or we have to reclaim it, or refining it through the process. Either there is an oxidation material, either there is soaps, there is resins, there is certain contaminations. All the neutralization property may be hampered due to this. So usually when we choose the insulating oil, we gone through the electrical part of the electrical properties of the insulating oil. These three basic electrical properties, as breakdown voltage, resistivity, and dielectric dissipation factor. And when we come across all these three factors in a place, so usually see the physical and chemical property of the insulating oil is already in place. So that's how we look into. Then we come into the part of the testing of the transformers. All that power transformer testing usually we carry out as per the IS 2026, and we usually do the three types of tests we usually discuss about. That is routine test, another is type test, another is special test. Special test I don't want to discuss elaborately because this is we don't usually do it very frequently. We usually do the routine test and type test. Type test is being done in the factory itself, but routine test definitely we do it in different site for the healthiness of the transformer. So as usual, we have to carry out in each job the measurement of the winding resistance, measurement of the insulation resistance, separate source voltage resistance test, high voltage test for HV and LV, induced over voltage resistance test, that is DVDF, double voltage, double frequency test, measurement of voltage ratio, measurement of no load loss and current, measurement of load loss and impedance, efficiency regulation test, vector group verification, oil VDV test, and test on OLTC. Test on OLTC usually we don't do. Right now, previously, we didn't do the OLTC arrangement in our power transformer, especially in 33 by 11 kV substations. But right now we are procuring the transformer with OLTC arrangement because it has got several advantages for 6.3 MVA and 10 MVA obviously. Now I just want to tell you that during the commissioning of the power transformer, what test we usually carry through. Number one is TTR, transformer trans ratio test. Transformer trans ratio test depicts so many parameters. That is the voltage ratio test. We usually do that in the same test. We usually do the vector group test. We usually do that same test, and the core balance test is also done. Now the DCR, DC resistance test, the core balance test, I told you the magnetizing current test and polarization index test. That's usually do in the during the commissioning of the transformer. Now I come one by one of it. The magnetic, the core balance test, the magnetic core balance test is conducted only on three-phase transformer to check the imbalance of the magnetic circuit. Usually what we do to do the core balance, whether core is perfectly or not, because we want to know that the uniform distribution of the flux has happened when the power is being fed into the transformer core is working properly or not. To do that test is very important, and very interestingly, we put certain voltage on on face-to-face basis. When we do the face-to-face with a certain voltage, suppose 400 volt AC on one winding, and we measure the voltage on other two winding, that should be the basically that's the vector addition of those this 400 volt AC. Now, if you do the vector addition of those two voltage of this YB and BR, it would be the same. In that case, we consider that magnetic. It is called also the magnetic balance test. That is HV side. That is carried through from HV side. But we do that is 400 volt AC we put in R and Y, and we measure the voltage in YB and BR. I will show you the test result. And if we do usually in three different tap positions, that is tap position number 1, tap position number 3, and tap position number 16. But our normal tap position is 5. But with different tap positions we do so that we can ensure that in any tap position the core is acting properly. If we voltage apply ROI for tap 1, suppose this is 400, we see in YB it will be coming 284.4 and BR it will be coming 114.5. If you add on these two, it is coming 400 volt. If we apply the same voltage to YB, in that case we get the voltage across RY is 188.4 and BR is 211.4. Again, if we add on this vector addition, it would come to the same value. Again, we put the voltage to the BR, the same voltage if we put, then if we get the voltage at 104.3 in RY and YB 297. Again, if you add on, it will be coming to the same value. So the same test we usually do in keeping the tap number 3 in position, keeping the tap in tap number 3 position as well as the 16 position, and we get the result. When we get the same result, we make sure that the code is acting properly. Then we come into the vector group verification test. Later on, we will do that. If you see, we do the same thing. We put 12 volt in RY. If you see, here I am showing you that RY is 400 volt, Rn is 7 volt, and Yn is 393 volt. If you add these two, it will come 400 volt. But vectorically, if you see there is Ry. If you put a voltage over there, certain voltage, maybe 12 volt, there should be certain voltage of against Rn neutral in the LV side. We measured that. Then again we put the same voltage to Yb and we measure Yn. And then again we put the same voltage to Br, then we measure Bn. So if you see the ratio of Ry by Rn, Yb by Yn, and Br by Bn, it will be always same. In that particular case, we usually come to know that vector group verification, that is usually in our 33 kV and 11 kV substations, we usually do the power transformer, usually choose the vector group of DYN11. Now you can ask me that why it is DYN11, why it is star from LV side. As because I have shown you in transmission, usually we use the delta, as because in delta, if you use the delta, in that particular case, we can use the 3 wire. But in case of star, when you use the star, you have to utilize 4th wire, that is as a neutral. But in our distribution system, if you see, we need face-to-face voltage as well as face-to-neutral voltage also. In our electrical system in domestic department, in a domestic area, if you see, we don't use face-to-face voltage. We always use the face-to-neutral voltage. In case neutral voltage is very important for us. So same way we use the DYN, the LV side is always a neutral. In distribution side, when you go for the permanent PMSS substation, pole mounted substations, the distribution transformer end, that is 11 by 0.415 volt, 415 kV. In that particular case, you see the same vector group we usually use because of this reason. But in case of 33 by 11 kV substations, in case of 11 kV, 33 by 11 kV power transformer, in 11 kV side, we usually do the same configuration, same vector group, as we experience that earth fault is frequent in 11 kV system, but it is not frequent in 33 kV or above system. So that's why to figure it out that earth fault system, our neutral is very much required. Neutral point is very much required. When I discuss in protection system, you will see. That's why we use the DYN11. So in that particular case, vector group verification we usually do choosing these things.